So our instructions here are to solve this system of equations by elimination. Now, what I'm trying to do is I'm either trying to eliminate the x's or I'm trying to eliminate the y's. Okay? So what I'm going to do is I'm going to multiply the top equation by negative 2. Because when I do, negative 2 times 4 is negative 8. So I'll be eliminating the x's. That's what I'm trying to do. I'm going to try to eliminate the x's in this case. Okay, so I'm going to multiply the top by negative 2. And when I do, negative 2 times 4x is negative 8x. And negative 2 times 3y is negative 6y. And negative 2 times 7 is negative 14. Okay, now what I'm going to do is I'm going to take this 8x and the negative 8x and I'm going to add them and I get 0. And I'm going to take this 6y and the negative 6y and I'm going to add them and I get 0 again. And I'm going to take the 14 and add it to the negative 14 and I also get 0. 0 plus 0 is 0. Does 0 equal 0? It does. Look guys, when all the variables disappear and what you're left with is a true statement, 0 does equal 0, that's a true statement, then the answer here is infinitely many solutions. Now some people will say all real numbers or all solutions. The answer is infinitely many solutions. If all the variables disappear and you're left with a true statement, the answer is infinitely many solutions. So this is our second example of solving system of equations by elimination. Okay, again we need to look and ask ourselves which variable do we want to eliminate. Okay, if I were to eliminate the x, I'd need to multiply the top equation by what? Negative 2. So that's what I'm going to do. I'm going to multiply the top equation by negative 2. Now when I do that, I get negative 2x minus 6y equals 10. Because I took negative 2 times x, and that gave me negative 2x. And I did negative 2 times 3y, and that gave me negative 6y. And negative 2 times negative 5 is positive 10. Okay? And now I'm going to add up what I've got. The 2x's cancel because 2x and negative 2x is 0. Y and negative 6y is negative 5y. And negative 10 plus 10 is 0. Now that's okay. We still have variables, so we're good. So now I'm going to divide by negative 5 on both sides. And so y equals 0. Now I know y, but I need to plug it into one of the equations to find x. The top equation is x plus 3 times what y is equals negative 5. So what I did is I took this top equation right here and I wrote it down right here, but in the place of y, see y was right here, I put what?
0.
0. So now I'm going to solve for x. 3 times 0 is 0. So I have x plus 0 equals negative 5. X plus 0 is x, and that equals negative 5. And so my answer is the two lines would intersect at the point negative 5, 0.
I thought I had.
Okay, again we have a system of equations and we're solving by what? Say elimination.
Elimination.
Say it louder.
Elimination.
Okay, now what I need to do is I either need to eliminate the x's or I need to eliminate the y's, right? If I want to eliminate the x's, what would I need to multiply the top equation by? Negative 1. So let's do that, okay? So I'm going to say top equation times negative 1. And so I get negative 5x plus 3y equals what? Not 10. Negative 10, because you've got negative 1 times 5x gives you negative 5x. Okay? You've got negative 1 times negative 3 gives you positive 3y. And negative 1 times 10 gives you negative 10, correct?
Yes, sir.
Now we're going to add them up. Alright? 5x and negative 5x is 0. Negative 3y and 3y is? And that equals 3 plus negative 10 is 3. So I've got 0 equals 3. Now, All the variables disappeared, and what I'm left with is a false statement because 0 does not equal 3. So I can put a line through the equal, meaning they're not equal. So when all the variables disappear and you have a false statement, then the answer will be what?
No solution.
No solution. And so what we're saying is we're saying the two lines are parallel, they'll never intersect, right?